Hello, my name is Monique Morton, and I am the Senior Content Director for Mathematics and Computer Science with Advanced Kentucky. And this is one of a series of videos reviewing optimization for AP Calculus. First, let's read our example. A particle moves along the x-axis such that its position at any time t, where t is on the closed interval from 0 to 5, is given by the function x of t is equal to 3 times t minus 3 to the 2/3 power times 2t minus 1. At what time t, where t is on the closed interval from 0 to 5, is the particle farthest to the left? Well, if we have our particle moving left and right along the x-axis, then the values to the left are the smallest values of x, and the values to the right are the largest values of x. So when I want to know when the particle is furthest to the left, I want to minimize x. So I don't need a diagram here because it's just moving back and forth along a horizontal line. And I've given my optimization equation. X of t is equal to 3 times t minus 3 to the 2/3 power times 2t minus 1. So I'm going to go ahead and take the steps to find the maximum value of this function. First, let's take the derivative. I'm going to use the product rule here. X prime of t is equal to 2/3 times 3 times t minus 3 to the minus 1/3 times 2t minus 1. That's the derivative of the first times the second, plus 3 times t minus 3 to the 2/3 power times 2. That's the first times the derivative of the second. I'm going to do a little bit of simplifying here. This will be 2 times t minus 3 to the negative 1/3 times 2t minus 1 plus 3 times t minus 3 to 2/3 times 2. Well, that should be a 6. So what I'm going to do is I'm going to factor out 2 times t minus 3 to the negative 1/3 power. 2 times t minus 3 to the negative 1/3 power. And I'd be left in my first term with 2t minus 1, and in my second term with 3 times t minus 3 to the first power, because I took out a negative 1/3. 2 times t minus 3 to the negative 1/3 power, 2t plus 3t is 5t minus 1 minus 9 minus 10. I'm factoring out of 5. 5 times 2 is 10 times t minus 3 to the negative 1/3 power times t minus 2. And to make it a little easier, since this is a negative exponent, I'm going to write this as a fraction. 10 times t minus 2 over t minus 3 to 1/3. So, took a little bit of work, but that's my derivative. In order to find my critical points, I need to set the derivative equal to 0, and I also need to check whether the first derivative is undefined. Note, I do have a domain. It was given to me that t is limited to be between 0 and 5. So whatever critical points I find, I only need the ones that are between those two values. If I set this equal to 0, let's see, x prime of t is equal to 0. That means the numerator is 0. So that's when t is equal to 2. And x prime of t is undefined, which we have to check in this case because it clearly has a value when it's undefined, when t is equal to 3. Both of those numbers are on the interval from 2 to 5. So critical points at t equals 2 and t equals 3. So I have 2 critical points to check instead of just 1. Now this is a good time to use the candidates test. We're on a closed interval and we have a couple of we have a couple of critical values to check. So what I'm going to do is to check the interior critical points, t equals 2 and t equals 3. I'm just going to make a table here. And I'm also going to check the endpoints for the function x of t. So 0, 2, and 3, and the right endpoint is 5. and I'm going to evaluate them at x of t. So here's my x of t up here, right? 3 times t minus 3 to the 2/3 power times 2t minus 1. So when I put 0 in for t, I get 3 times negative 3 to the 2/3 power times negative 1, which is 3, negative 3 actually. So negative 1 times 3 is negative 3. And I'm going to write this as 9 to the 1/3 power. So clearly that's a negative number. So thinking that might be a candidate for being farthest to the left. But put 2 in for t, I get 3 times 2 minus 3 is negative 1 to the 2/3 power times 4 minus 1, which is 3. So that actually comes out to be 9, okay? Because negative 1 to the 2/3 power will be 1. If I put 3 in for t, I get 3 times 0, right? Because 3 minus 3 is 0, so this is going to be equal to 0. And when I put 5 in, 3 times 5 minus 3 is 2 to the 2/3 power times 10 minus 1 is 9. So I'm going to write this as 27 times 4 to the 1/3 power. And it was asking when it was farthest to the left, right? So I want the minimum value of x. Well, this value here is negative, so the minimum value must be occurring when t is equal to 0. So therefore, the particle is farthest left when t is equal to 0. So when you're given a closed interval, it's a good chance to use the candidates test, but our steps are pretty much the same, right? We start out by reading the question, realizing what we're trying to minimize in this case or maximize in other problems. We had our optimization function given to us, so we didn't have to do any work to find it. We did have to do a little bit of work to find the first derivative, though. We found the values where the first derivative is either equal to 0 or undefined. And then we used the candidates test, right? And I just created a table because it's easy to organize. Evaluating at the endpoints and the interior critical points on the interval given and seeing which value is actually the smallest value. And that actually occurs at t equals 0. So the particle to the left is farthest left when t is equal to 0. Very important to take the time to actually answer the question. This arrow I put up here wouldn't be enough. This is Monique Morton from Advanced Kentucky. Thank you.